Welcome to the third technical lecture for the political economy of the environment. Today we will address three methods commonly used in benefit-cost analysis: contingent valuation, the value of a human life, and discounting. I'll briefly describe how economists use each of these tools to inform environmental policy. I'll also discuss potential problems with these tools, especially how they can produce studies that undermine environmental justice. The first tool in benefit-cost analysis is contingent valuation. One way for economists to estimate the benefits of environmental policies is to simply ask people their willingness to pay or willingness to accept. Economists might ask people how many dollars they are willing to pay to create a new state park or reduce noise pollution. Alternatively, they might ask people how few dollars they'd be willing to accept in exchange for allowing the destruction of a local wetlands or the construction of an oil pipeline. If a survey suggests that 100,000 people are willing to pay an average of $20 for a new state park, a benefit-cost analysis would support its creation if the cost of doing so were less than $2 million. Contingent valuation can lead to biased estimates of environmental benefits and costs because it is based on how much money people say they are willing to pay or willing to accept, as opposed to how much money they are actually willing to pay or willing to accept. Contingent valuation may suffer from hypothetical bias if respondents do not take the survey questions or their answers to them very seriously. It is also possible that respondents overthink their answers. Contingent valuation may be biased by free riding, in which people understate how much they would be willing to pay for environmental goods because they think they may actually be asked to pay that amount. Contingent valuation may suffer from strategic bias, in which respondents overstate how much they'd be willing to pay because they believe that their willingness to pay will have no impact on their own contribution to the project, but that saying that it is worth a lot to them will make it more likely that the project goes forward. Economists have also shown that contingent valuations are often subject to embedding bias, in such a way that respondents' willingness to pay and willingness to accept depend on how the questions are framed. However, even if these biases are insignificant, contingent valuation can intentionally or unintentionally undermine environmental justice. In general, low-income people are willing to pay less than high-income people for environmental goods. As a result, a benefit-cost analysis that uses contingent valuation may recommend lower levels of environmental protection in poor areas. A second tool in benefit-cost analysis involves placing a value on human life. Many environmental policies, including regulations ensuring clean air and water, save lives. To compare the benefit of lives saved to the costs of environmental protection, we must determine the value of each life. A common way of doing that is analyzing how much money people receive in exchange for increasing their risk of death. For example, police officers faced a 1 in 10,000 greater probability of being killed each year than the general population. Suppose that police officers are paid $700 more each year than their peers with similar qualifications working in less dangerous professions. Since 10,000 police officers each receive $700 annually to accept the loss of one police officer's life, police officers are implicitly valuing their lives at $7 million. This example suggests environmental policies that can save a life for less than $7 million are worth pursuing. There are substantial problems with using these methods to place a value on human life. First, it seems unlikely that most people have a very good information about how risky their jobs really are. Second, the most dangerous jobs are generally paid poorly, while the high-wage jobs are generally quite safe. Although it is possible that among otherwise identical workers in riskier professions receive higher pay, it is not necessarily true. Finally, this method of placing a value on human life could perpetuate environmental injustice. If poor people are more willing to live in toxic neighborhoods or take more dangerous jobs, should we conclude that their lives are worth less? A third tool in benefit-cost analysis is discounting. Since environmental policies often have both short-run and long-run benefits and costs, we need some way to compare these benefits and costs over time. Economists generally assume that $100 next year is worth less than $100 today. The current value of future benefits or costs can be calculated using this formula. The present discounted value equals x divided by 1 plus r to the t power, where x is the future costs or benefits, r is the discount rate, and t is the number of years in the future the benefits or costs will occur. An example may illuminate this formula. Imagine a policy that would create $100 of environmental benefits in 10 years, 50 years, or 100 years. What cost should we be willing to bear today in exchange for these future benefits? The formula for present discounted value and a discount rate of 0.01, or 1%, suggests that a benefit of $100 in 10 years, 50 years, or 100 years is worth bearing a cost today of $91, $61, or $37. A higher discount rate of 0.05, or 5%, suggests that a benefit is worth a cost today of $61, $9, or 76 cents today. And a discount rate of 0.1, or 10%, suggests that future benefits is worth a cost of only $39, 85 cents, or 0.7 cents today. The choice of the discount rate is crucial for determining the desirability of policies with benefits or costs far in the future. Discounting raises slightly different issues around environmental justice than a contingent valuation or placing a value on human life. Benefit cost analysis with high discount rates will tend to support policies that impose environmental costs on future generations. Consider an analysis of whether we should build a coal-fired power plant that will impose $100 billion in costs on our great-grandchildren a century from now. If we use a discount rate of 1%, then we should build a plant if it provides at least $37 billion in benefits today. But if we use a discount rate of 10%, then a plant would only need to provide $7 million in benefits today to pass a benefit cost analysis. In short, we're much more likely to decide to build a plant and impose environmental costs on our great-grandchildren if we use a high discount rate. In this lecture, we have identified a lot of potential problems with benefit cost analysis. Despite all these difficulties, the strength of benefit cost analysis is that it forces researchers to clarify why they support or oppose a given policy. Learning the language of benefit cost analysis will help you examine under what assumptions a policy does or doesn't make sense. Developing your fluency in benefit cost analysis will help you in this class and beyond. Thanks for listening to your third technical lecture on the political economy of the environment.